Hello! So it's Easter again! Last year, I brought you a tutorial for a game called Hop to the Top, and I never imagined it would be as successful as it was. This year started off as a proof of concept for something I'd seen and wondered if I could do on the Amiga. In this video, we'll take a look at my new game, Bunny's Boing Ball Bounty, the speedrun challenge, and we'll see how it works. Firstly, let's take a look at the game. As you can see, the game starts up with a simple title screen. Oh, and the bunny graphic on that screen was generated using Windows Copilot. Not bad. Also, the music was kindly provided to me by Virgil. Now, if I leave this running for any longer, I'm sure the rabbit bouncing will really start to get annoying. So let's start the game. And here it is, a rabbit bouncing its way around a sphere. Some of you may remember a very similar bonus level in a certain hedgehog related game. Could be where I got the idea from. So, the aim is to collect all of the eggs and complete the level as quick as possible. So there's obviously a strategy to the route you take. Once you've collected all of the eggs, you'll be taken to the next level. And if you fail to complete the level, then it's game over and you'll be given a total time. You may also get given a code to record your speedrun on my shiny new internet scoreboard. Simple, eh? Well, I created this game in AMOS. I've included the source code with the game. So let's see how it was made. And the first step was to generate the background ball image. Now there's many ways I could have done this, but I've opted to code this myself. I created a small Windows program that generated a 3D sphere as a set of vertices and then render it to the screen. Now this took quite a while to get right, and after a lot of horrible maths, I finally managed to make something that looked about right, as you can see. But this is static and we need it to move. Now that's easy for a fast modern computer, but I want this to run on my old Amiga 500, and as fast as possible. And we need the ball to roll forward. Now I decided to use a total of 8 frames to advance to the next segment of the ball. Now we can just render those 8 frames and use them, which will work, but it's not the most efficient method. Problem is, every frame we essentially need to redraw most of the screen, and that's quite a lot of work. There is, however, a far easier way to do this. If I re-render the ball and split each segment into 8 strips, and then I give each of those 8 strips a different colour, then we can use a special trick to animate this. Loading this into AMOS and issuing the shift down command, you can instantly see it starts moving. This command is cycling the palette. If I stop it and change the palette to be black and red, you get this. And finally, white and red, and you get the familiar Boing Ball. I'll show you this in Deluxe Paint so you can see what's happening. First by setting the range and then hitting the tab key to start the cycling. As you can see, nothing's actually moving, we're just changing the palette. The downside to this method is to keep the background black and have 2 sets of 8 frames, we need a total of 17 colours, meaning this has to be a 32 colour screen. Still, that gives us extra colours for the items we'll be putting onto the ball, and as you saw, that's a really quick, low CPU way to do the forward motion. But what about the rotate? Well, that's a bit more complex, and we can't use colour cycling for that, so unfortunately, we'll have to store some frames. Like the forward motion, I want the rotate to take a total of 8 frames, which you can see here. Obviously you'd be flipping the palette around to make this seamless, but we don't actually need to store all 8 frames. The first and the last frames are just our normal moving image, so we can get rid of those. Looking closely at frame 2 and 8, well, one is just the flipped version of the other. The same goes for frames 3 and 7, and 4 and 6, leaving us with just 4 frames. Now these images aren't going to need any colour cycling. So, we can save memory by storing them as a 4 colour image. Less colours also means it will draw faster to the screen. I actually store them all on top of each other and on load read them back into an AMOS image block using the get block command. Now remember we have to draw some of them flipped sometimes. Well, there's an easy way to do this, but it's a little bit strange. AMOS has a command called href block, which will horizontally flip an image block. So, because of the way it does this, I need to keep track of the flipped state already so that we get the right version. The other thing is the palette. On first draw, the palette for this needs setting instantly to get rid of the colour cycle palette from before, and then restored when we go back to the original image. Okay, so we have a Boing Ball that we can move forward and rotate, that's perfect, but we need some map data too. Now I've decided to make the levels 16 by 16 in size, the size being optimised for speed and the edges wrap around. Now as you move around the sphere, you end up facing in lots of different directions, which means working out what's in front of you is calculated differently for each direction. Based on what's directly in front of you, you can only actually see, including one row immediately behind you, 6 rows, and a total of 11 columns. So I wrote a procedure to tell me what's in these locations that were correct for the rotation. The problem was, calling this for every frame for every position ended up being very slow. So I wrote a new procedure to cache this into memory for the start of each of the 8 frames. This massively sped up this information. One thing you may be wondering about is the coordinates I'm actually using to draw these items on the screen. Well, I cheated a little here. When I generated the original Boing Ball images, I saved out the positions of the corners of the ball squares. I then imported them into an AMOS memory bank so I could use that as a quick lookup. So this only leaves one other thing, and that's the actual items on the map. Firstly, we have our rabbit bouncing at the front. Well, this is just a simple 8-image, 4-colour animation, rendered on screen using the first 2 sprites. The extra sprite, number 9, is displayed while the ball is rotating. However, if we zoom this sprite up, you can see it's larger than 16 pixels wide, and that's why we have to use 2 sprites for it. On the actual ball, we have 2 types of Easter egg, an energy drink can, and a bomb. These also need to be available in a number of sizes too. Now ideally I'd like everything to be sprites, but that's not going to work. The problem being that to display as many as possible, we need to use AMOS's computed sprites. But there's limits on how this can work. To maximise their use, we'll also need to use 4 colours, and due to the way the colours are assigned to these sprites, the rabbit will occupy the first 4 colours. But to keep all the eggs looking the same, as we don't know which hardware sprites AMOS will use, we'll have to set the remaining sprite palettes to be the same, leaving no possibility to use sprites for energy drinks or the bomb image. So, I decided to combine sprites and Blitter objects, or bobs, leaving the eggs drawn as sprites, but the energy drinks and bombs drawn using bobs. Sprites are much faster, so it makes sense to use them for as much of the actual objects on screen as possible. And we can use the remaining transparent palette entries for their colours. I'm not going to go into any detail about drawing bobs and double buffered screens, as I've covered this several times in previous videos. Now I know that wasn't as detailed as some of my videos in the past, but it was meant more of a proof of concept than anything else. Now feel free to play with the source code that's on the disc, and let's see how many of you can get on the high scoreboard. I do have one challenge for you though. There's a little glitch in the game caused by the bobs at one point. See if you can fix it. I never got around to figuring out what triggered it. Anyway, I hope you found this interesting, enjoy playing the game, and thanks for watching, and I'll see you in the next one.